Hey guys, here's the end of your notes that I wasn't able to do on the meet today. I just wanted to show you, I did go ahead and graph this parabola. We were able to convert it to vertex form to see all of the transformations. The vertex was -2, -3, so I plotted that. The a value was 2, the number in front of x squared. We know it's positive, so the parabola is opening up. And then a little bit of 1a and 3a gets you a 2 jumps and 6 jumps. So I just went right 1 up 2, right 1 up 6, and then I matched it on the left side. Okay, so that's just the graph of that parabola, just so you could see it finished. And then I want to finish the last two examples with you. So this example says, write the equation of a parabola that has a vertex at -2, 5 and passes through the point 0, -7. So they're asking you to write the equation of the parabola. You have two formulas basically to work off of when you're asked to write the equation of a parabola. You have standard form and you have vertex form. Guys, they gave you the vertex. So your best bet is to take vertex form and plug that information into it. So they've asked us -2, 5, and it also has to pass through the point 0, -7. So just plug the vertex in. So y equals a times, if it has an x coordinate of -2, that would have been x plus 2 quantity squared. All right. And then if it had a y value of 5, that would have been plus 5. And then the only thing we really need to know to officially write the equation of the parabola is the a value. So you can take the point they've given you, and you can borrow it and plug it in as an x and a y value, and then you can solve for the a value that is needed. Okay, so we're going to plug -7 in for y equals a times 0 goes in for x, and then we'll solve this for a. So it'll be -7 equals, that's 2 squared is 4 times a is 4a plus 5. We'll minus 5 to the other side, get -12 equals 4a, divide both sides by 4, and a equals -3. So then you just pop that right in there and you have your equation. So it'll be y, or f of x, equals -3 times the quantity x plus 2 squared and then plus 5. And if they ask you to write it in standard form, all you have to do is FOIL this, distribute the -3, and combine like terms. And then you'll take your vertex form to standard form. Another thing you could have done is plug the vertex in, -2 and 5. Another thing you could have done to get a is, the vertex is at -2, 5, right? So there's -2, 5. It passes through the point 0, -7. 1, 2, 3, 4, 5, 6, 7. Right 1 would have gone down 1a units, and then right 1 again would have gone down 3a units. So that means that 1a plus 3a would have to equal, well, what's the total drop from your vertex to this point? I went 5 and then -7. -12 units is what 1a and 3a would have added up to. So then you could have said that 4a is equal to -12, and then a again is -3. So just another way to get the a value. All right, so that's how you can write the equation of a parabola if they're willing to give you the vertex and a point on the parabola. Okay, all right, the last example just says, describe the transformations made to the graph of. So again, if you're going to look to graph anything using transformations, again, if I'm you, I would just do a little bit of -b/2a, plug it in, and just treat this like a standard form parabola. However, if they are specifically asking you for transformations, the only way to figure out the transformations is to see the parabola or the equation of this parabola in vertex form. So we're going to have to complete his square to put him into vertex form. All right, so just let me rewrite it. Okay, so again, I'm just going to rearrange, get myself set up for completing the square. F of x equals -2x squared plus 6x plus something better that'll make it a perfect square trinomial. Oops, sorry, I hope I was on camera. All right, and then we'll put the plus 2 out here, and then I'm going to make room. If I'm going to add some random number, I might as well minus that random number to keep it balanced, right? Almost, bud. All right, when we go to complete the square, I cannot have anything in front of x squared, so we're going to factor out the -2. So f of x equals -2 comes out. That leaves you with x squared minus 3x now. We haven't created this number yet, so don't worry about pulling out a negative sign. It should always be plus the last number in a perfect square trinomial, and then close that, and then we'll leave the plus 2 and the minus something on the outside. All right, so now we can complete this square. The better number is always half the middle squared. So guys, half the middle, it can be -3. It really doesn't matter, even though it is -3. The sign won't matter because we are squaring it. So half the middle is half of 3, which is 3/2, and then we square it and we get 9/4. So we're adding 9/4 to this side. Now, before you go ahead and add 9/4 to this side, you have to remember you didn't really add 9/4, because if you ever multiply the -2 back in, -2 times positive 9/4 is -9/2. The 2 and the 4 will reduce. So you really are adding a -9/2. So I better minus a -9/2 as well on that side. All right, so now this is a perfect square trinomial, so it'll complete the square. F of x equals -2 times. This will factor to, if you notice, when you go to complete the square, it's always half of that middle that ends up in the parenthesis. So it's going to be half of that -3. So it'll factor to an x minus 3/2 and an x minus 3/2. That becomes x minus 3/2 quantity squared. And then when I go to add this together, that's really going to be 2 plus 9/2. All right, we get a common denominator. That's 4/2. All right, so 4 plus 9 is 13 over a common denominator of 2. So plus 13/2. All right, so there we go. So now you are converted to vertex form. So now you can see that the vertex would be 3/2, 13/2. So what, 1.5, 6.5. And now we can describe the transformations. So this -2 is obviously new to the outside of the function. So that would be -2 times the y values, which would cause, number one, the negative would cause an x-axis reflection, right? It would take the parabola from opening up to opening down and reflecting it over the x-axis. All right, that +2 times the y's then would cause a vertical stretch by a factor of 2. So the y values have been changed to the opposite sign and made twice as big. All right, this -3/2 is clearly inside the function, so it's being done to x, but we know it always is the opposite of what it appears. So if it says x minus 3/2, this is really going to be taking the x's and adding 3/2 to them. So this is going to take the whole graph and shift it to the right 3/2, or 1.5 units. All right, and then last, this plus 13/2 is on the outside. So who are you really adding that 13/2 to? The y coordinate. So that would be the y's plus 13/2. So that would take the whole parabola and move it up 13/2, or 6.5 units. Okay, and those are the transformations. And again, those are the transformations to the graph of y equals x squared, right? The mom and dad of all parabolas. You would take all of his original ordered pairs, take all of his original x coordinates, and add 3/2 to them. That would bump the whole graph to the right 3/2. Then you would take all of the y coordinates on the original graph, times them by -2, and then add 13/2 to them. You do it in the order of operations. So if y has more than one transformation, you perform those transformations in the order of operations. So first you would take all the original y coordinates, times them by -2, and then you would add 13/2 to them. And that would move this parabola to his new home. Okay. All right. So guys, that's all the notes that I was not able to get in. So always reach out to me if you have any questions.